Mishler Math back on the air. Similar polygons is what we're talking about. We're going to define similar polygons, and we're going to use the properties of proportion and scale factors to solve problems involving similar polygons. Now, dilations create similar figures. The first thing we had was dilations. They create similar figures. And similar just means this. Corresponding angles are congruent. Angles, corresponding angles are congruent. And corresponding sides are not congruent, they're proportional. And I'll tell you what I mean by that. Suppose we have triangle A, B, C here, and let's see if we can do this right. Triangle A, B, C, and triangle D, F, E. Now the first thing I'm going to tell you is that this angle and this angle are congruent. This angle are congruent, and this angle and this angle, 1, 2, 3, 1, 2, 3, are congruent. So what I just said was angle A is congruent to angle D, angle B is congruent to angle F, and angle C is congruent to angle E. Now be careful with this, because our congruent statement then says triangle ABC is similar to triangle DFE. Notice the order of the letters is important. You have to go in the order according to what's congruent to what. Now, this part about the corresponding sides being proportional, what that means is side AB, or I'm sorry, I don't put that on there because it's talking about the length. AB is to DF the same as BC is to FE, and that's equal to CA over ED. What that means is the ratio of this side to this side, this side to this side, and this side to this side, those ratios are all the same. Remember, a proportion is when we set two ratios equal to each other. So all these three are equal to each other. So let's talk about let me tell you what I mean when we talk about that, okay? Get rid of all this. And let's try a couple of actual triangles here. Let's see. We got one here. And we got another one here. Oops. And my thing is kind of growing crazy here, so bear with me here. And see if we can get this right. Anyway, I guess we'll have to work with it the way it is. And so we've got, on this first one, we've got RPQ. RPQ. And the second one is UST. UST. Maybe I can fill that in this way. There we go. Kind of looks like a triangle now. Alright, UST. Now, I'm going to show the congruent sides here, or angles first. This angle and this angle are congruent. This angle, I'm going to do this way. Those are congruent, and these angles are congruent. So, and the sides are in this proportion. The sides look like 26, 20, and 38. Yes, I know it's not proportional, but bear with me. This is 39, this is 30, and this is 57. So, what we've got here is the question is, are they congruent? Are these, or excuse me, are these two, is triangle RPQ similar to triangle UST? That's the question. So the first one, we look at the angles. Angles. And I should say corresponding angles are congruent. So that's the first thing. Corresponding angles are congruent. The second thing is sides proportional. Are the sides proportional? And we find that out by going like this. We got RP over US. Okay, that's 26 over 39. Now if we divide the top and bottom by 13, we get 2 over 3. And so that looks pretty good, doesn't it? And then let's try changing colors. Let's get dynamic green here, going RQ over UT. Okay, let's see, RQ is 20 over 30. Divide the top and bottom by 10 and you get 2/3. And one more, we've got PQ over ST, and that is 38 over 57. Now, if we divide the top and bottom by 19, we get 2 over 3. So since the ratios are all the same, then yes, the triangles are similar. And this one little wavy line like that, that means similar. Okay? What about proportions? What are we talking about proportions? I'm going to show you some products, or some properties, rather, of proportions. Again, remember, a proportion is like this. A over B equals C over D. And if A over B is equal to C over D, then AD equals BC. What this is a cross multiplication property. And you might recognize this because you've been using it for quite a while. You just cross multiply. A times D, AD, B times C, BC. So this is how we've been solving problems for quite a while now. And let's try another one. We got A over B equals C over D. Well, that means that B over A equals D over C. Notice what I did. I just flipped each fraction upside down. And of course that is called the reciprocal property. And there's another one. A over B equals C over D. That means that A over C equals B over D. Now, I bet you didn't know that one. A over B, we can switch these two. You see what I did? I switched these two. I put C on the bottom over here. I put B on the top over here. And what that is called the exchange property. Okay, I can exchange these two. I can also exchange these two if I want. Okay, so, but I can only do that kitty corner like that. I can't do it right straight across. I can't do that. All right, one more here and we're done. And that is A over B equals C over D. That means that A plus B over B equals C plus D over D. And that is called the add 1 property. Why is that called the add 1 property? Well, if you got A over B and you add B over B, well, this is equal to 1, isn't it? B over B is equal to 1, whatever B is. Okay, so what does that equal? A plus B over B, which is what I have here. So basically I just added 1 to each side. And here I did the same thing. D over D, I added D over D to C over D, and so I have C plus D over D. Okay, I hope you got that all figured out now. And we got another one we're going to do here. Control, delete, clear that. And let's take a look at something here. Ah, there we go. We have a couple of similar pentagons. And we have to use these properties to figure out what AB is. Okay? We've got dimensions all the way around here, but we don't know what AB is. So we're going to use the properties that we've just learned, and we say, you know, we know that AE over FJ. Okay? Here's AE, and here's FJ. Okay? That is going to be equal to AB over FG. Here's AB, which we don't know, and here's FG, which is 16. So it makes it pretty simple to solve. AE is 15, FJ is 20, and that equals AB, which is AB, over FG, which is 16. Okay? Now, we're just going to use the cross multiplication property. And 15 times 16, 240, equals 20 times AB. Divide by 20, and we get 12 equals AB. And just to make sure, go back and take a look. 15 over 20, does that equal 12 over 16? Well, if I divide both top and bottom by 3, I get, excuse me, if I divide the top and bottom by 5, I get 3 over 4. If I divide the top and bottom here by 4, I get 3 over 4. 3 over 4 equals 3 over 4. So everything checks out there. So that's nice and pretty, isn't it? Let's try another one. This time, you know that within a figure we can change these around using the properties we just learned. we can change these around and show that I can even show proportions between the same figure. What do I mean by that? Let's try mn over yz. Now mn is just the bottom segment on both of these. These two are similar figures. Okay, equals nk over zw. Okay, well, I'm going to use the exchange property, and I'm going to put mn over and yz over and put nk down here and zw down here. You see what I did? I just took the nk from up here and I put it down here. And what that means is that now I've got the proportion between mn and nk is the same as the proportion between yz and zw. Okay? So, if that doesn't make sense, it will once we start doing some problems. Page 511, 6 and 8. These are your practice problems. And your homework is page 512, 12 through 24 even. Thank you very much. We'll see you soon.